Happy learning! Today we're going to talk about applications, in particular marginals and derivatives. Okay, so we're going to talk about marginal revenues, costs, and profits today. So let's just start with an example. If the price function if the price of a product is given by $16 minus 0.02x, right? This is saying if you want to sell X units, this is what price you should list it at, right? You can think of it as like a demand function. I want us to first find revenue. And then I want us to find the marginal revenue when x equals 40. All right, so this is really straightforward. We need to find our revenue function, and then to find marginal revenue, remember marginal revenue, marginal anything, is the derivative. All right, so we need to find our revenue function, and then its derivative at x equals 40. Easy, right? So let's find our revenue function. If this is the price to sell X units, our revenue is the price times the number of units sold. This is our revenue function. And we are welcome to leave it like this. But if you look, step B says we need to take its derivative. This is a product. So to take its derivative would require the product rule. So what I'm going to do is I'm actually going to simplify this function just to make our life a little bit easier when we take its derivative. All right, so distributing this x to both of the terms, we get negative 0.02x squared plus 16x. Right, we could have just went ahead and sucked it up and done the product rule to take the derivative, but it's just so much easier when you have a polynomial. All right, so our marginal revenue, which is just the derivative of our revenue function, is negative 0.04x, right? We bring the power in front, subtract 1 from the power, plus 16. All right, in our marginal revenue, when x equals 40, we just sub 40 in for x, and we get 14.40. All right, and so what this is saying is selling that 41st unit. All right, so selling that next unit after 40, so that 41st unit, will increase our revenues by approximately $14.40. All right, that's how we interpret this value here. All right, so I said today's just going to be application, so it's going to be a lot of examples. So if you like examples, give me a smash of the like button, all right? So let's take a look at another one. Suppose that the daily cost in dollars for a factory to produce X blenders. All right, we're looking at a blender factory here, is given by C of X equals 0.001 x to the third minus 0.3 x squared plus 32x plus 2,500. All right, so we have this cost function. For any value of x, this tells us the cost to produce x blenders. Let's find the marginal cost. All right, so let's find the marginal cost function. And let's interpret the marginal cost marginal cost when x equals 80 and x equals 200. All right, so the marginal cost, marginal anything, is the derivative. So let's take the derivative of our cost function. Our marginal cost is the derivative of our cost function. We bring the power in front. Subtract 1 from the power. We do that for each of the terms. OK, so that's our marginal cost function. And now we need the marginal cost when x equals 80. And then we'll do it again when x equals 200. But this is really, it's just a matter of plugging a number into a function. So easy peasy, easy peasy. OK, so let's look at c prime of 80. Right, c prime is the same thing as marginal cost. C prime of 80. We just type that into a calculator, and we get 3.2. OK, so producing that 81st unit increases our cost by about $3.20. C prime of 200 is 32. So producing that 201st blender increases our costs by $32. So at that point, we might be pushing our employees to the limit, or we might be needing to expand. Maybe that's where the cost comes from. But either way, it seems like as our number of units increases, or at least at some point, our marginal costs get bigger and bigger. So keep this in mind when you're determining how many to produce. Unless you're selling the blenders for a lot, $32 for that next blender is quite a bit of money. OK, let's continue. It's not always going to be the case that the models for our cost or revenue or profit functions are nice polynomials. It's possible that we have some messier looking functions, but we're powerful students, right? You guys are powerful. You know how to take derivatives of almost any function, so you can handle it, all right? So don't stress. Everybody's stressing about a square root. Don't stress about a square root. It's just the same thing as something to the 1/2 power. All right, so if the total profit in thousands is given by P of x equals 20 square root of x plus 1 minus 2x minus 22. I want us to find the marginal profit when x equals 15. All right, so don't go freaking out about the square root. You can handle it. So what do? We rewrite our function. Instead of having the square root symbol, you have it raised to the 1/2 power. And then we could just use the power and chain rule. All right, so let's do that. our function, our profit function, is 20 x plus 1 to the 1/2 power minus 2x minus 22. All right, so let's take the derivative of this. Right, the derivative gives us the marginal profit. Bring the power in front. 20 times 1/2 is 10. X plus 1. Subtract 1 from the exponent. And for the love of God, remember the chain rule. Boom! Times the derivative of the inside. What is the derivative of x plus 1? It's just 1. So those of you, and you know who you are, I'm looking at you. Those of you who forgot the chain rule are lucky this time. Okay? But your luck is going to wear out. So remember the chain rule. Right? We bring the power in front. Subtract 1 from the power. Boom! Derivative of the inside. Even if it's 1, it's good to keep track that we're using the chain rule. All right. Derivative of minus 2x is just minus 2. And the derivative of minus 22 is 0. All right, so we want to find the derivative. So we want to find the marginal profit when x equals 15. That's p prime of 15, which is going to be, let's just rewrite this. X plus 1 to the negative 1/2 is the same thing as the square root of x plus 1 in the denominator. This will make it a little bit easier to type into a calculator. But it's 10 over root 15 plus 1 is 16 minus 2. Which is equal to 0.5. OK, so our profit increases when we go from that 15th to that 16th unit by 0.5 thousandths. Okay, it increases by $500 from when we go from that 15th unit to that 16th unit. Okay, let's look at, well, at least one more. Okay, so a firm sells its product for 200 beans, 200 buccarinos per unit. All right, 200 bucks per unit that this company sells its product for. The cost per unit, okay, this is not the total cost. This is the cost per unit, is 80 plus x. All right, so this is not the total cost, but this is the cost per unit is 80 plus x. What I want us to do is find the marginal profit. I know what you're thinking. How do I get the marginal profit? We don't have a profit function. Okay, we got to find the profit function. Right? We remember profit is how much you bring in minus how much you spent. It's your revenue minus your cost. Okay, so let's find the revenue function. Let's find the cost function. And then from there, it's very easy to find our profit function. And then to get marginal profit, we just take a derivative. All right, so our revenue function is we sell the product for $200 each. If we sell X, our revenue is 200 times X. Our cost function, well, we know the cost per unit is 80 plus X. So our cost function is our cost per unit times the number of units, which is just X. All right, and I'm going to clean this up a bit because we're going to eventually take a derivative. We're going to eventually take a derivative, right? Because it says marginal profit. So we eventually will take a derivative. Here we have a product. Right? We could use the product rule to find the derivative, but it's just so much easier if we factor, or distribute, sorry. So we have our revenue function, we have our cost, we could find profit, right? Profit is our revenue function minus our cost function. So let's distribute the minus sign and combine like terms. This is equal to negative x squared plus 120x. All right, so what is our marginal profit function? Our marginal profit is P prime of x, which is negative 2x plus 120. Okay? So even though we weren't given a profit function, we were able to build it using the information that was given to us. And then from there, we take the derivative. Okay, so what's the big takeaway today? Marginal anything is the derivative. But keep in mind, we have all of these derivative rules that we've learned over the last few videos. So make sure you apply them when they're appropriate. Okay, well, that's all I got for this unit. So I will see you in the next one. Bye-bye.